I'm Jabril, and today I'll be explaining the recurrence relations. So in this problem, we have a method accumulate that takes integer n. And to explain part A, the recurrence describing the runtime of accumulate n in terms of n is 1 times t n half plus n half. The reason why we have 1 here as the coefficient is because in the method, we only call accumulate the recursive portion one time. And the reason why it's t of n half is because n half represents the size of the problem in each recursive call. Although in the method, we don't see m over 2 because we're calling accumulate m, but at each iteration of the for loop, m increments by 1. However, the for loop runs n half times as I increments by 2 at each iteration. This is also the same reason why the non-recursive work is described as n half. And for part B, for my diagram of the first 3 levels, it starts off at t of n, and then t n half, t n 4, and then t n 8, and so on until it reaches the base case of 1. And for the non-recursive work, we see that it starts off as n, and then n half, and then n over 4, and then n over 8. Because there's only one recursive call, this diagram has no other children besides each node has one child. And essentially, the reason why it goes from n to n half is because at each call, we're dividing the input data n by 2. So n divided by 2 is n half divided by 2 is n over 4 divided by 2 is n over 8, and then as this keeps going on, we'll eventually reach the base case 1, which for the non-recursive work would just be described as n, which is also why the final order of growth is n. And the reason we know it's 1 is because the hint from the next slide sort of gives us that hint that the base case is the final order of growth. And in this case, the base case is when n is less than or equal to 1, as the recursive case is when n is greater than 1.